So, good evening everyone. We are the 18 reporter. By the way, I am Marvic B. Abergonzado together with my co-reporter Ryan Lorania Perez. And we will discuss about the aftershock. So, before we will tackle aftershock, we should know earthquakes. So, what is earthquakes? Earthquakes are unpredictable and can cause severe damage to buildings and structures. So, kabalo naman taon sang earthquake, no? It cause damage sa ato ang mga infrastructure, sa ato ang mga building. So, kita nga mga civil engineers, mga future civil engineers, we should ensure, dapat i-make sure na to nga to ang mga building is safe and quality para sa mga tao nga magamit sa to ang buildings or infrastructures. And also, aftershocks are also a significant risk factor that needs to be mitigated. Next, Madi. So these are our overview. We have first the preparing for earthquakes. So designing and constructing buildings to withstand the effect of earthquakes. So as a civil engineer in the future, we should prepare for earthquakes. So dili lang ta basta-basta dapat daw mag-design og buildings or magpataka-taka lang tag-design og buildings nga dili ma-withstand sa any nga disaster. So dapat i-make sure jud nato nga ato ang buildings na ginapatukod or na ginapahimo is safety sa mga magamit sa ato ang building. So safety para sa mga people. So second, we should assessing structural damage. So, methods for evaluating structural integrity and the aftermath of an earthquake. So, after an earthquake, we should i-evaluate daw nato kung okay ba ang ato ang structure, and after an earthquake kung naabay tay nakita nga mga cracks kung okay ba ang ato ang building. Third one, we have mitigating earthquake damage. So, strategies for minimizing damage and protecting life during an earthquake. So, dapat yun nga, same thought lang, dapat i-make sure talaga natin ang ating building is maka-withstand sa earthquake. So, fourth, we have the improving earthquake awareness. So, educating the public about earthquake safety measures and emergency preparedness. So, kabalo naman taani no kay di ba gina-implement naman na or ginahimo naman nato ni karon, like gina-improve nato ang skills for the incoming earthquake, ginabuhat nato nga the cover and hold. So also as a civil engineer dapat inform pud nato ang other people how to be safety during an earthquake. So, di ba? So, kung kita ang engineer sa kana nga so kita ang engineer sa kana na building, dapat dili kita ang una magdagan-dagan, no? Kay kung kabalo lang man ta nga quality ang ato ang gipatukod na na building. So, make sure pud nato na dili ta mag-una-unag dagan kay kita na gani ang nagpatukod sa building, dapat kabalo ta ingon nato sa ibang nga tao nga safety ang ato ang building. So next, we will talk about the definition of aftershocks. So kabalo naman taon sang aftershocks. So what is aftershock? An earthquake that occur after a larger earthquake, the main shock in the same area. So yun ang aftershock. So how are they different from pre-shock? So pre-shock from the name or from the word itself. So pre-shock after the main shock, naatay pre-shock na mahitabo. So it is usually daw smaller or less frequent sa ato ang aftershock. So, what is causes aftershock? They are caused by the readjustment of the earth crust after the main shock. So that is my part. I will give the stage to Ryan.
So, as per continuation of what have been discussed by Ms. Marivic Gonzado, so my name is Ryan Aranya Perez, and I will discuss the effects of aftershocks on building and structure. First is the structural damage. Aftershock can cause further damage to already weakened structures and buildings, potentially leading to collapse. So, as the as the building experience earthquake, so may possibility na mag-collapse ang building if meron tayong mga aftershocks. So, the second one is the cable and suspension bridges. Cable and suspension structures are susceptible to damage from aftershocks due to increased vibration and tension on the cables and suspenders. So we have the methods for assessing earthquake damages. First, we have the visual inspection. Visual inspection are the inspecting buildings and structures for visible sign of damage such as cracks and leaning. So when we say about visual inspection for earthquake damage assessment involves a thorough examination of structure for visible signs of distress such as cracks in walls, beams or foundations such as the misalignments. This process helps engineers and experts identify the structural weakness and determine the safety of a building after an earthquake event. So the second one is we have the seismographs or the recording ground motion to assess the structural damage and estimate the strength of magnitude of an earthquake. So the second one we have the seismograph. It plays a vital role in assessing earthquake damages by recording the ground motion data during an event. This data helps scientists and engineers analyze the earthquake magnitude, location, and duration. By studying seismographs, reading, they can estimate the potential damage, prioritize response effort, and development better earthquake resistance building designs to minimize the future destruction. So the third one is we have the remote sensing. Remote sensing is using an aerial or satellite imagery to capture the extent of damage over a large area. So when we say about remote sensing, it is a crucial for assessing earthquake damages by providing the high resolution satellite imagery and aerial photographs. This image helps identify affected areas, structures damaged, and changes in topography. Remote sensing aids in rapid damage assessment, aiding disaster response and recovery efforts while enabling informed decision making for resource allocation and recovery planning. So, our the last one is the UAV or the drones. So, the flying small and un, unarmed aerial vehicles to inspect concrete structure and buildings to a close distance. So when we say about UAVs, drones are it is valuable tools for assessing earthquake damages. They capture high resolution aerial images and 3D models of affected areas, enabling rapid and detailed image assessment. Drones provide in real-time data, enhance situational awareness, and assist in identifying hazards, helping emergency responders and authorities make informed decisions for effective disaster management. And we have these mitigation strategies for reducing aftershocks damage. So first we have the isolate structure. So it is use isolation systems such as base isolation to minimize the transfer of energy between the ground and the building during an earthquake. When we say about isolation system is an earthquake engineering is a structural mechanism designed to minimize the impact of ground motion during an earthquake. It is typically involve placing flexible bearings or insulators between a building's foundation and superstructure, allowing the structure to move independently of the shaking ground, thus reducing seismic forces and protecting the building from damage. So, one of the examples of isolate system is FGM of Ramon Magsaysay. So the second one is the retreat from hazardous areas. So avoiding the construction of buildings and structures in areas known for high seismic activity and landslides. So we engineers, we build structures na dapat dili duol sa mga fault lines, dili duol sa mga duol sa mountains which is prone to landslides. So the third one which is the reinforced current buildings and structure. Reinforcing and existing buildings and structure to withstand the effect of earthquakes and aftershocks. So, gina-reinforce or gina-retrofit na to ang isa ka weekend. So, when we say about Retrofitting of a building refers to a process of upgrading or modifying existing structures to improve their resilience and safety against various hazards such as earthquake, floods, or energy efficiency. This typically involves the strengthening foundations, aiding the support structures, and enhancing isolations, and implementing other measures to bring older buildings up to contemporary safety and efficiency standards. So the fourth one, we have the early warning system. So providing early warning system and emergency response procedure to minimize the impact of earthquake and aftershocks on people lives and properties. So as a citizen, so we should be equipped, we should know what to do and what to does during an earthquake. So kailangan dyan na to maging prepared sa earthquake. So we have the case studies of structural aftershock mitigation. First is the Sendai subway system. So following the 2011 Tohoku earthquake, the Sendai subway system used an isolation system to minimize the impact of aftershocks on the subway tunnels and passengers. So ang Sendai subway system doon is nagamit sila ano, isolation system, which is na I've said earlier. So for them, for us, the building can mitigate the aftershock. So the second one, we have the Taipei 101 Tower, or the Taipei 101 Tower, one of the tallest buildings, uses a damping system to avoid the energy of earthquake and reduce the building swaying. So ang Taipei 101 po nagamit po yung other system, which is ang damping system to mitigate the aftershock. So the third one, we have the Alaska Highway Bridges. So after the 1964 Alaska earthquake, the Alaska Highway Bridges uses a chic retrofit method to prevent damage to the bridge piers and abutment during the aftershocks and landslide. So, ang Alaska Highway Bridges daw, gigamitan daw og retrofitting for us na mitigate ang aftershock. So, the last one, we have the future of aftershock mitigation. So, while ongoing scientific and engineering developments, including computational simulations and machine learning algorithms, it is expected that aftershock mitigation will continue to improve. Collaboration among professionals and stakeholders is critical to ensuring seismic safety and reducing the damaging effects of earthquake and aftershocks on the people and infrastructure. So our scientists, our engineers, our professionals, and our stakeholders is nagapangitag paraan para ma-mitigate to lessen the aftershocks. And also, measure, they have the strategies aimed at reducing or preventing the negative impacts of various hazards like earthquakes. So that would be all. Thank you for listening. Goodbye.